Nice one. We're back with Gabriel Potvin from Let's Talk Science. He's also a graduate student at U of O. And we're going to work with liquid nitrogen now?
Yes, we are.
That's always a good one.
It's a lot of fun.
Hey, yeah. And it comes in a canister like this?
Absolutely. Has to keep very cold. So liquid nitrogen here is at about minus 200 degrees Celsius.
Is that right?
So very, very cold. So nitrogen is just the gas that's in the air.
Yeah.
That,
is it used for anything else? Like it's fast freezing of
absolutely. So in fact, if you go to the pharmacy and you buy some of these wart removers, for example, that freeze it instantly, that's what it is. Usually they're liquid nitrogen based. And we use it for all sorts of stuff in research.
So with wart treatment, it actually freezes the wart and then the wart falls off.
Exactly. You can remove it very easily.
So you got to be careful with this stuff.
Yeah, very careful. Yeah.
Because like if I stuck my bare hand in there, maybe my hand would fall off.
That's why I'm wearing
And I wouldn't like that. At all. Okay, go ahead.
All right. So what we're going to do, we're going to start by pouring a bit of liquid nitrogen in this foam container here.
Right.
So you'll see it just looks like water, but it is at minus 200 degrees. Okay, we're going to put quite a bit.
That's crazy. Something that's minus 200 degrees and it's not frozen.
Yeah.
You can feel how cold it is just over here.
Just if you put your hand in the kind of vapor coming out, you'll see even the vapor's cold. Okay, so we've got a lot in that container now. And you can see it bubbling.
You almost filled it.
Yeah, you can see it bubbling because it's evaporating. Okay, so we'll be very careful with that.
So it must evaporate at a high rate, eh?
Absolutely. So it is at minus 200. So at about minus 180, it'll start evaporating. So because it's obviously hotter than minus 180 here, it starts evaporating.
Right, and now this is getting warmer and warmer.
Exactly.
Okay, good.
All right, so what we're going to do with this is something fun. We're going to freeze some roses, and we're going to see what happens to the roses when we do it. So I'm going to ask you just to dip the rose in the liquid nitrogen. Okay. It's going to take a few seconds, but you can see it's really bubbling.
Is it ever?
And what I have here, this is a rose that we're not going to freeze.
Okay.
And so we'll be able to see the difference between the two. So while this is freezing, if you just lay it on the side like this,
yeah.
We'll just let it freeze for a couple minutes.
Okay.
What I have is another experiment. So we've been working something very cold. We're going to work with something very hot.
Okay.
So what I have here is a piece of cotton. So I'm going to ask you to stick out your hand. Great. We're going to put a little piece of it in there. Small piece. Okay, just like this. Very important you don't drop it. Okay, and I'll show you why.
I'm not afraid, by the way. I'm not afraid.
No.
Nothing to be afraid of.
We're going to take a much bigger piece.
Yeah.
Fluff it up a bit, right over here. We're going to set this cotton on fire and we're going to see what happens.
That cotton right there?
Yeah.
There we go.
All right.
Whoa.
All right. So
what happened?
That's obviously not regular cotton. This is cotton that was soaked in a derivative of dynamite, TNT. Okay? So you're holding TNT in your hand, and what we're going to do, we're going to light this on fire right in your hand.
Am I in a movie right now?
You ready? Make sure your hand is open.
Okay, yeah.
All right, maybe you want your stuntman to come in.
Right.
All right, 1, 2, 3.
Poof.
There you go. Did that hurt?
No.
It burned so quickly, it didn't have time to burn your
It doesn't have time to. No, you just feel a quick flash of heat.
Exactly. Yeah.
That's how they do those magic tricks.
You get all sorts of special effects like that.
Yeah. I knew it. Are roses frozen?
So roses should be okay now.
Oh,
yours actually fell out and fell to the bottom. So you can see it just cut right off.
Am I going to be able to get it?
I do have some tongs here. Let's see if we can just pull it out.
Oh, come on, fella. I want to see you.
There you go. I think we got it. It's so fragile. Okay, so what we're going to do, I'm just going to smash this on the desk and we'll see what happens.
Okay.
Okay.
Oh my gosh.
All right, so it looks just like glass, and we'll do it with this one too.
Wow.
And you can see with a regular rose, obviously doesn't do this. No. All right?
How cool is that?
So when it's really, really frozen, it can't absorb any shock. The molecules can't move anymore. So when you hit it, all of the shock goes to where it's breaking it. And it's like shards of glass. So you heard the kind of glass shard sound when we did that.
Yeah.
So it makes a nice little mess like this, and these are still very, very cool.
Really cool stuff, Gabriel. When are you're gonna be active this weekend? Where are you gonna be?
Absolutely. So we'll be at the Booth Street Complex from Natural Resource Canada for Science Fun Fest this Sunday, October 14th from 11 to 4.
It's National Science and Technology Week. Gabriel's with Let's Talk Science. Very cool. Thanks for coming by.
Thank you very much.
Nice to meet you. There go the roses I was gonna get you, honey.
So smile.
We're back. Oh, is this the Rose song, Panger? Good job, buddy. Good job. Here we go. We'll take a break. We'll be right back.